So charges generate their own electric fields. So if you have a point charge at a certain location, the electric field that it generates is given by this equation here. So this is saying the electric field at some radial distance away from the source charge, r, is equal to k times q source over r squared r hat. K is a fundamental constant. It's the electric constant. You can see it written there. You can also see it written in terms of the permittivity of free space, epsilon naught. K is equal to 1 over 4 pi epsilon naught. They're equivalent ways of writing those fundamental constants. You have Q source in the numerator. Q source is the charge on your source charge. So if you have a charge at some point in space, it's generating the electric field that you see here. Divided by r squared, r is the radial distance away from the source charge. So depending on where you're looking, you are a distance away from the source charge, which we write as r. And then r hat is the radial direction, telling us about the direction of the electric field. So r hat can either point radially outwards or radially inwards towards a source charge, depending on the sign of the charge. We can visualize this in a couple ways. So if I have some test charge here, let's say that's my test charge. I'm going to label this as, source charge, Q source. And if I want to measure the electric field, maybe some distance out here, I can start to label some of these quantities. So the distance from here to there, that's r, that radial distance away from the source charge. And my electric field, in this case, if Q source is positive, r hat's telling me it's pointing away from the source charge. And so my electric field might look like this at that location, maybe something like that. Okay, so that's telling me that this is going in the positive r hat direction. Now, if I wanted to, I could think about maybe an even closer position here, right? So now, from here to here, that's my new r, if I'm interested in this new position. That r is smaller than the r we had before, so my electric field, given that I have Q source over r squared, I've got a smaller number in the denominator, my electric field magnitude should increase, although it's still pointing positively away. So I would draw a bigger vector, something like that, to represent what my electric field would look like at this new closer location. If my source charge changed signs, the only thing that would change about my pictures here is now my arrows would be flipped around, pointing towards Q source instead of away from Q source. So that is the electric field of a point charge and how you can sort of visualize what it looks like in a representation.